one extra factor r coming out. So this is indeed a cylindrical coordinate system region. Okay? So in the cylindrical coordinate system, we're using r, theta, and z variables. And this three-point triangle of any given function, f, x, y, z, dv is going to be equal to, from alpha to beta, from A to B, exactly the same as the polar coordinate system. And from a lower function, g1 of r theta to g2 of r theta, which are the lower surface of z, upper surface of the z. And then I need to replace everything by r and theta, where x is r cosine theta, y is r sine theta, z. And then I need one more factor, r here. So dz, dr, d theta. So this is the general formula for the cylindrical coordinate system. So this coordinate system is really just a polar with one additional variable z here. So nothing is seriously changed. What do you mean? So r here is the
For this one,
oh, it doesn't really matter that much because strictly speaking, I really should put it in front of that. Okay? So here, this is the general formula for a three-point triangle with respect to the linear coordinate system. So in this coordinate system, x, y are still having the same relation as the polar coordinate system with r and theta. The only thing which is added here is just the one extra factor z. Okay, that's about it. You still keep the same factor r, and everything has to be changed from x, y, to r, and theta, and you're done. Okay. Now, what is left is over there. I wanted to finish my evaluation. So it's from 0 to 2 pi, from 0 to 4. So I'm getting a square root of 32 minus r squared minus r multiplied by r dr d theta. Okay, so this is what we have. Okay. And then I need to find the antiderivative functions for these guys. One of the functions is pretty simple, it's r squared. It's a polynomial, everything would be nice. The other function is r times square root of 32 minus r squared. We have dealt with this type of antiderivative just a minute ago. Right? We actually just dealt with this, only differ by a constant. So from 0 to 2 pi, from 0 to 4, so it's r32 minus r squared minus r squared. dr d theta. I need to find the antiderivative function for the inside, which I have already done before I came to today's class. I find it as minus 1/3. 32 minus r squared 2/3 minus 1/3 r cubed. Then evaluating from r equals 0 to r equals 4. Then outside d theta. Again, if I'm not 100% sure about my antiderivative, I take the derivative. I'm getting an r squared right here. Here I'm getting a 32 minus r squared. Pull down, I got a 1/2. And then 2/3 pull above, I have a 1/2. And then when I go inside it using the change rule, I'm pulling out a 2r minus 4. That will cancel with the minus sign and getting a 2. Okay? So you can take the derivative. These things are all single variable terms. So I will give you a couple of examples, but for most of the other ones, you need to do yourself. Okay? And then you need to plug in the numbers and evaluate whatever number you have. That's going to be the volume of this Haskell code. So right now we have covered cubes, z simple, x simple, y simple, and cylindrical coordinate system region. The only thing which is left is the spherical region, which we'll cover after the spring break. So here is my suggestion. For the double integral and triple integrals, I acknowledge it's more challenging than the derivatives for a very natural reason. Right? Derivatives is going straightforward, whereas taking integrals, even finding the antiderivative, is going backwards. That's the first thing. Second thing, you already paid hundreds of dollars for a textbook. Start reading it. Okay? You don't want to use it as a break. Start reading it. And the other thing I want to stress again is, if you find the problems online to be too complicated, you cannot get the final answer I'll be happy to check your work, but you have to present your work in a presentable way. Okay. So I don't want to spoil your spring break. Okay, I don't want to intentionally spoil your spring break. But our second midterm is going to come 1 week after the spring break, covering all the intervals. Okay.
All the week after?